This is a freaking XSS payload. What the? Hi, welcome back to the new video. And in today's video, we are going to be talking about a crazy vulnerability that combines the combination of XSS and OAuth account hijacking. So this vulnerability was found in Salesforce application. So we're going to look at it and how this worked. This is very unique, by the way. This is something I didn't see before. So I really wanted to share it with you guys. Let me just zoom it out. Yeah. Hope this is very much visible to you now. Stealing Salesforce OAuth tokens using the WAF. Now that I know a title sounds a bit crazy, using the WAF, how's that possible? Using WAF, usually WAF blocks you from doing something malicious, but yeah, that's actually one of the unique things about this bug. Because the person who found this bug, let's see about Raphael. Okay. So he's the one who found this vulnerability. Really wanna give him a shout out because this was crazy for real. Recently, while running a pen test on a Salesforce instance, I found an XSS vulnerability. This post breaks down the bug and how I escalated it to steal OAuth tokens by leveraging Cloudflare WAF as a gadget. Due to NNT, let's call the target redacted.com. Okay, before we totally dive into the exploit, I want you to get a little bit introduction about Salesforce Applications. Salesforce Commerce Cloud is an e-commerce application that can help you run stores online. So SFRA over here is storefront reference architecture, some fancy name. So this is actually a name of the framework that help you build storefronts, basically a collection of components, templates, and controllers. So now you must be wondering, what are controllers? Controllers in Salesforce handle HTTP requests and render HTML responses. So there are a lot of controllers and every controller has a different name and has a purpose. It's like functions basically, but in Salesforce you call it controllers. Okay, so now that you have a little bit context, let's read. Salesforce Commerce Cloud provides mature security baselines, so vulnerabilities often hide in merchant customizations. Specifically, this is true, custom templates or components. In this case, the endpoint renders a specific component based on a configuration provided via request parameters. So a prime example is the SFRA Storefront Reference Architecture controller, and the name of the controller is Einstein Carousel Load. This controller allows the storefront to dynamically load recommended products for a carousel section and expects 2 parameters. So basically, you've seen carousels, you can just Google it up. It's basically like a template storing images of a particular product. So this controller expects 2 parameters, like a request. So limit. The first one is limit, a number representing the maximum count of recommendations to display in the carousel. So another one is components, a JSON encoded array of component config objects that define how the carousel is rendered. Okay, so since the components parameter directly controls the rendering output, it becomes a potential injection point if an attacker can tamper with it. Digging through the Kaido history, I found requests using this controller that looked like this. Okay, so this is how the endpoint looks like. We have a GET request, on demand where.store, site redacted, obviously, and then English, and then Einstein carousel load, and then component, because there was a parameter, and equals, and then we have components value. So this is a components value. It has template, product. This is the path for the template, and the color of the template, and the model, which contains type and an ID. So the server renders this into HTML as follows. So this is how it looks in the HTML response. So we have the button tag, data, border, and then we have some other stuff. So as you can see, the value provided here, the color hash value is injected over here. It's basically getting reflected over here, data background, in the data background as well, as you can see, and class and other things. So by playing around with the key main color, we can see our input reflected in the rendered HTML as attribute value inside the button tag. I confirmed that we could break out of the attribute context by changing it to this value. Okay, this does make sense. Changing out of the attribute context, we often do that when it comes to XSS, trying to break out of the context and trying to inject our own payload. This is what we're trying to do over here as well. So this is something simple, closing the attribute value and then injecting a random attribute and a value. So after doing that, the reflected value looks like this. So it's just a way of testing to see if we can break out of the context or not. Then only you move on to the actual payload. A lot of people, what they do, they just spam in the payload, copy paste it and see if it works or not. Actually, you have to break down the XSS payload to the simplest form first to see what is working, what is not working. So the first step over here was to see if actually you can break out of the context or not. So yeah, it's working. So these were some random values, but since it is working, it means we can actually inject some other values as well. So from here, it's about crafting a payload that escapes the attribute context. Interesting thing is a lot of things were getting blocked here, like events like on focus, on error. There are a lot of events. He provided also the cheat sheet, Portugal XSS cheat sheet as well. A lot of them didn't work here. After testing a bit, I found that on content visibility auto state change, that's a long name, was viable, though I was still constrained by the WAF filtering. The WAF blocked words like focus, style, as I said, a few usable patterns for this event. However, I managed to bypass the filter by using Unicode escape. So Unicode escape looks like this for S. This works because the backend is processing the input via JSON parser. This you can see as seen in the controller code. Okay, let's look at the code. Looking into the code, so this is the controller code for InstantCarousel.js. And looking at this, okay, where is the JSON parser? Okay, we have it here. JSON.parse request query string.components, basically parsing the values from the components, the component parameter that was being passed in the path, the path we saw earlier. I meant this path, the components parameters. Okay. With that in mind, we send the flowing payload to achieve XSS. So after trial and error, found the final payload that looks like this. So we have the main color here, then putting in a quote to escape out of the attribute context, and putting in another on content visibility auto state change, and then its value to confirm. Okay, before I read on further, you must be thinking, what is this even? What is on content visibility auto state change? This is actually an event. So this event fires or get triggered when the content visibility state changes. Now, still sounds a little bit confusing, right? So it is actually tied to a CSS property, content visibility. So if there is something that you wanted, like you don't want it to render when the user is not on the particular screen, you can stop that rendering process. And if a user is getting back to the screen and you want to render that particular element, you can render it in their browser. So these are like two states, hidden and visible. So element is off screen, then the browser won't render it. That is hidden state. And if the user is on screen and the element is visible, it will render it. So it was actually defined for optimizing things in the browser. So the browser doesn't have to, do a lot of rendering, and it will slow things down, obviously for user-friendly purposes. So you're getting the point. It is just about content visibility. Okay, so we have a function confirm here, which is similar to pop-up, what you see in alert. So over here, instead of the circular braces we usually see whenever we call a function like alert and then circular braces to call a function, instead he's using a backticks here. Backticks does the same thing, but using backticks here is actually a smart idea because this way the WAF won't be able to detect it. So it's a good way to bypass. Okay, so now we have Unicode character here. So it's actually style, but instead of S, he's using this Unicode character for S character, that is this value. And then for this attribute, we have this value display block, content, visibility, auto. So these are actually CSS specific values. Display block makes the element block type of element, and without content visibility, this will never fire. So this is needed over here. In short, what he just did here is basically created an element of block and then set its CSS style, or whatever you call it, property, content visibility, to auto. So It means that if the user is not seeing this block, it will be hidden. It will be in a hidden state, and if he's seeing this, then it will be in visible state. Okay, so as you can see over here, it's written same thing. Note on content visibility auto state change only fires on elements with content visibility auto. So the injected CSS in style enables the event and triggers the inline handler. So now the goal is to turn this constrained access into something more flexible, allowing us to iterate without constantly fighting filters. So that's why instead of typing in more code over there, he tried to use a remote script by injecting a source over here as well. So analysis.js, which is posted somewhere else, basically including that script by creating a script element and then including it in the source attribute of the script tag, and rest of the things remains same. So this is a perfectly working payload. You can do multiple things with it. This is already a crazy XSS payload if you look at it, pretty smart. But now the idea is something else. We want to use this XSS to steal OAuth tokens. Okay, so let's see how the idea came in his mind. Login with OAuth. It's time to escalate. What are our options? Stealing session cookies isn't possible because Salesforce enforce HTTP only cookies. Okay, cookies attacks like cookie jar, overflow, cookie testing, or cookie sandwich were not applicable in this case. And changing the victim's email and password wasn't possible either because it requires knowing the current password. So there isn't much currently that we can do with this XSS payload. So what we can do. However, one functionality caught my eye was that the application allowed SSO login via Google or Facebook. This is pretty interesting. So this is the whole the flow of it. Okay, so the thing is, I don't want to make this video too long. If you don't understand how OAuth works, please watch the video from the I button, and once you get the idea, come back to this video, okay? And if you just want to look at this diagram, we can look at it. So I'm just going to explain it once. You send a post request that goes with dsrf and redirect URI, and then the client application sends it to the IDP server. The IDP server provides you an OAuth code, and the OAuth code is exchanged for an access token. So the idea over here is to steal the OAuth code, because once you have the OAuth code, you can exchange it for access token, and once you have the access token, you can send authenticated request on behalf of a victim user. Basically, you can perform any actions, or you can say you're basically logged in to the victim's account. This is crazy. So the objective is to intercept the code and state parameters when the IDP redirects back to our origin. With these values, we can redeem them for an account session and achieve account takeover. To do this, we must halt the redirect chain at step 5 because the code is one-time use, obviously. So basically, somehow we want to stop the application at step 5 where it gets the code, and we don't want the application to exchange it for access token because we want to steal that code. Teaming up with WAF. Now this is the interesting part that I was talking about. You'll get this meme once I read this param. The idea is to leverage the Cloudflare WAF to block the redirect from the login OAuth re-entry callback by planting a malicious cookie. This prevents the code and state parameters from being redeemed, allowing us to steal via XSS since we are back on our origin. Here are steps we need to perform. So basically what he's trying to do, using the XSS he found earlier, he's trying to add a cookie, a malicious value in the cookie, and it forcing the WAF on purpose to trigger, a WAF block. Because once the WAF block is triggered, step 5 will be freezed in that phase where we have the code and the state parameters, and simply using the JavaScript in our XSS payload, we can fetch that code and state parameter, and then we can have an account session. This is the idea. Initiate the OAuth flow by inserting an iframe. So obviously, how we're gonna deliver this attack? Delivering this attack is basically by using an iframe, which is pointing to IDP login URL. Wait for the iframe to load the interior back to our origin and steal the unused code and state parameters from the iframe URL. So this is how the flow looks like right now. Okay, so that flowchart was nice, but there were not steps written there, like step 1, step 2. I thought it would be a little bit confusing for you, so that's why I asked Cloudy to make a flowchart so you can understand what's happening after what. So we have normal flow here. User clicks login with Google on redacted.com, redirects to identity.redacted.com, and IDP redirects to Google, where user authenticates. You click on approve, deny, right? So approve an application to access your data. And then once you do that, Google returns code plus state. So obviously, as I said, our goal is to stop this step right over here so we can steal the code and state. But in normal state, what happens after this is IDP redirects to login, OAuth reentry, in this case of Salesforce. This is what the path looks like, login, OAuth reentry, keep that in mind. And in the parameter, we have code and state like that. Code is redeemed, session created, and user is logged in. Simple, easy, good to go. But this is how the attack flow looks like. XSS runs on redacted.com because we found XSS earlier, right? Attacker has JS execution. So now what we're gonna do, we're gonna force logout victim. We are using this function so the victims log out. So once the logout is forced, why we're doing a forced logout? Because if the victim is already logged in, we cannot initiate OAuth login, right? So we wanna make sure this works, so logging it out. And then we are grabbing the Google IDP URL. We are doing that because we want to initiate the OAuth flow on behalf of the victim. Once you grab the Google IDP URL, we are planting a malicious cookie. So this malicious cookie will go in the HTTP cookie header, HTTP cookie header. So in that, we'll have this value. So this is a simple payload, looks like SQL injection. And looking at this, the server, Cloudflare is going to think that it's an SQL injection payload, and that's what we are forcing it to think that way. We'll know why. Okay, so we are starting OAuth in iframe, and the source has the IDP Google URL, WAF blocks login OAuth reentry because cookie triggers 403, code is frozen. And then we read the iframe URL via JS. So we are able to do that because iframe is in the same origin as our XSS payload. Okay, they both are on redacted.com. So same origin allows this. So because of that, we can steal the code and the state, and then we can log into victim's account. Let's go back to the blog. I don't expect you to understand it in one go because it took me few hours to understand this, but you can just read this blog by yourself and watch this video again so you can understand it better, because I'm literally doing everything to, simplify things for you so you can understand it. So yeah, this is how the whole code looks like. It's freaking huge. Okay, so what I just explained you in the attack flow is exactly what is happening here. So the first step, we are logging out victim. So this is the path to log out the victim, and then we are fetching the Google IDP URL, and then we are setting the malicious cookie, document.cookie, to this SQL injection value. They're setting an iframe. In the iframe, we are adding the source to start the OAuth flow, and then over here, once the WAF triggers the error, we will get the code and the state in the URL, and because it's in the same origin as iframe, we'll be able to steal it using this code. So u.search_param.get code and u.search_param.get state, and then console.log session code and session state. This is literally crazy. As you can see, this is how this looks like. Session code over here displayed and session state as well. Wow, that was amazing. This was literally amazing research. I'm going to link this blog down in the description. If you have any questions, you can ask it out in the comment section. Okay, so I really had fun reading this. And since we're talking OAuth, I wanted to mention that I have created my first members only video. In that, I have shown hunting on a live target. Actually, all the videos that I'll be uploading for members only, I'll be showing approaches and testing features, functionalities, everything on live targets, either from bug buddy platforms or choosing target from Dorking or whatever. I would love if you check that out, because I talked about OAuth account linking bug, and that was freaking cool, testing it out on live application. So do check that out from the link in the description. And yeah, that's it for today's video. So yeah, don't forget to like and subscribe, and I'll see you in the next one.